Welcome to today's tutorial. So in this tutorial we are going to discuss how we can solve different types of questions under analytical geometry. So if you have not yet subscribed to the channel, make sure that you click on the subscription button and don't forget to click on the notification button so that you don't miss out the videos that I'm going to be posting. And then if you have any questions or you want to join my lessons, the online lessons that I conduct for physics, math, chemistry, feel free to contact me using these lines on the screen. Alright, so let's quickly begin with question 1. So question 1 says the standard form of the equation of the ellipse with center at 4, -2, and then the focus we have f1, which is 4,1, and f2, which is 4, -5, and the minor axis length has been given to be 10. So this is a very simple question which I believe will not take long to solve. Alright, so the first thing that you need to understand is to know the type of geometry that you are dealing with. So in this case we are dealing with an ellipse. So we know an ellipse can either be along the y or it can be in the x. So we know that if it's in the y, what is the standard equation if it's in the y is going to be, the standard equation if it's in the y is simply so it's in the y, so meaning you have y squared over a squared plus x squared. Okay, let me write it this way. So I was saying if you have the one that is in the y, then the other one is in the x. So if it's in the y, you expect your equation to be let me start with x squared over b squared plus y squared over a squared is equal to 1. So for this one you take the orientation of the ellipse. I mean you know the orientation of the ellipse by checking the variable that contains the value of a. So if a is under y, you know to say the ellipse is directed along the y or parallel to the y axis. Yes, or you say the major axis is parallel to the y axis. So if the major axis is the longest distance in this ellipse, so if the major axis is parallel to the x-axis, then you expect the value of a to be under x. So these equations that I'm writing now apply for the ellipse which has the center 0, 0. Okay, so these are the equations if their centers are 0, 0. Or let me say, okay, if the centers are 0, 0, and then if the center is h, k, meaning if the center is defined by a certain coordinate, then the equations will be x minus h squared over b squared plus y minus y minus k squared over a squared. This is equal to 1. So you do the same. So I'm just trying to remind you about the equations. So you have x minus h squared plus y minus k squared over a squared over b squared is equal to 1. So these are the equations that you're supposed to use. Now read through the question again. The question says find the standard form of the equation of the ellipse, and then we've been given that the distance from the distance from one point to the other point in the minor axis, from this point to that point, or from that point to that point, is equal to 10. So we know that we have a major axis there. We know that the distance from the center to that point is the one that we call, is the one that is denoted by B, and then the distance from the center there to the major vertex there, yeah, is the one that we call A. And then the distance from the center to the focus, the distance from the center to the focus is the one that we call C. So now the question is, how do we find the value of B and the value of B squared and the value of A squared? Or how do we know, by the way, how do we know first of all, how you know, I mean, how you do assist, how you determine the orientation of the ellipse? So how do you know? So the orientation is determined by checking the coordinates that you've been given. So you know that it is only in the x where you find y being constant, and it is only in the y where you find the value of x being constant. So in this case, we can check the coordinate which is constant in the ones that have been given. So we have 4 there, we have 4 there, we have 4 there. So if x is constant, we can know, or we can conclude to say this given ellipse is directed along the major axis of our ellipse will be along, or will be parallel to the y-axis. So meaning we expect something that looks like this. So now if we have something like this, this is our center, these are the vertices, then we have the first focus there, then the second focus there, F2, then this is F1, then we have the distance from that point to that point. So we've been given that the length from this point to that point is 10, meaning from this point to that point we have 5. And remember what we said, this distance from the center to one minor vertex in the oasis, in the minor axis, is denoted by B. So our B is simply just 5. So we have managed to find B. B is equal to what? 5. And then the other thing that you need to find is the value of what? The value of C, because we've been given the focus. If we are given the vertices V1 and V2, we would have just gone directly to find the value of A, because those are the only things that we don't have in the equation. Yeah, so what I'm trying to say is the equation is supposed to be, so this is the center which has been given. The center is 4, -2. So our equation is supposed to be like this. X minus 4 in brackets, then we have squared, then everything over what? Over B squared, and then we have plus, we have y minus. So since there's a minus there, we expect to have a plus there. So that if we equate that to 0 to find the value of the y coordinate there, you find that it will come to -2. So this is what we have, and then we have a squared, and this is equal to 1. Okay, so now so we've managed to find the value of B, because we said the distance from there to there is equal to B, and it has been given that the distance from this point to that point is 10, meaning we have found B there, which is 5. Okay, so now how do we find the value of A? So finding the value of A is simple, because we have been given the focus, and we know that the distance from the focus to the center is C. So now how do you calculate this value of C? So you simply just subtract the center and one of the focus there to find C. So if you subtract 4 and 4, you get what? You get a 0. And then if you subtract this, I'm just trying to simplify things, but in the actual sense, you're just supposed to subtract this number there and that number, which will give you +3. Yeah. Or if you want, you can subtract this number there, -2 minus -5. So you subtract the center, you say the center minus the center minus one of the focus. So here it was supposed to give us -3, because if you say -2 minus 1, the answer will be -3. Then if you say -2 minus -5, the answer will be +3, which is just okay, because this shows the displacement, the displacement of the focus, the point from the center. So we expect this coordinate, so this is how it's supposed to be. If you want, you can subtract this, you can say this minus that and this minus that. The answers will still be the same. So the sign here will not matter, because when you square this sign, when you square this value, you still have a positive answer when you square it. Because what we have just found here is the value of c, and we know to say when you're dealing with ellipse, c squared is given by a squared minus b squared. So c squared is equal to the value of a we don't have, is what we are trying to find right now. So we don't have the value of a, so I'm going to leave it as a squared, and then we say minus b squared has been given, we have found it to be 5 there, so we say 5 squared. Even c, we managed to find c, which is 3, so we expect to put 3 there. So 3 squared gives us 9, so this is equal to a squared rather minus 5 squared, this will give us 25. So you take this to the other side of the equal sign, you find that your a squared will be 9 plus 25. So a squared gives us 34. So here the equation will be x, sorry for that, so we say x minus 4 squared over b squared is 25. Oh, sorry, yeah, b squared is 25, and we say y plus 2 squared over a squared is 34, so you put your 34 there, then this is equal to 1. So this is how simple it is. In case I've made any mistakes in calculating, the procedure is correct, so you can just follow the procedure and find the correct answer. But I believe this is the correct answer. Let's move on to the next question. The next question says find the standard form. By the way, this is the standard form of the ellipse that we were trying to find. Remember what I told you, the value of a is always greater than the value of b when you're dealing with the ellipse. So let's move on to this one. It says find the standard form of the equation of the hyperbola that has the eccentricity 3,2 with the center at the origin and the focus at 6,0. So here we're talking about the hyperbola. So when you find such a question, you need the first thing you need to know is to understand the geometry which you are dealing with. So in this case, we're dealing with the hyperbola, which looks like this. So the hyperbola looks like this. So I'm just trying to do a sketch here. Sorry for that. So the hyperbola looks like this. Let me draw the asymptotes first. So you have it will look like that, and sometimes you have it in this orientation. Okay, so how do you find the standard form of such curves? So let's see how to do that. So the first thing that you need to know is to understand the first thing you need to do is to write down the equations. So we've been told that the center is at the origin, so our center is 0, 0. So now how do we know that this is the type of geometry we're talking about, or it's this one? So let's write the equations down. So for this one, the equation when the center is 0, 0 is for this one it's x squared over a squared minus y squared over b squared is equal to 0. For this one it's y squared over a squared minus x squared over b squared is equal to 1. So the way you know that this is in the x or this is in the y is by checking the value of a. Rather, it's by checking the value that is positive. So the term that is positive tells you the orientation of the geometry. So if the value of x is the one that is positive, you expect the curves to be in the x axis. Yeah. And if the orientation is and if it's y, if y is the one that is positive, then you expect the orientation to be like this. Alright, so let's quickly discuss this one. So we have this, and it has been given that the eccentricity is 3 over 2. We know that eccentricity is given by c over a. And then they are telling us to say the center is 0, 0. It's at the origin. And the focus is 6, 0. So remember, for the ellipse, we said c squared is given by a squared minus b squared. But for the this one is for the ellipse. But for the hyperbola, our c squared is given by a squared plus b squared. Yeah. So this value of a is the distance from so this value of a is the distance from, if for the ellipse the value of a was the distance from, let me draw it here, was the distance from the center to the vertex there. And then for the hyperbola, the value of a is simply the distance from it's also the same. If you have two let me do this. So they are saying the center is the origin. So the distance from the center there up to the vertex there is the one that we call a. It's the one that is denoted by a. And the distance from this same point to a point somewhere there, from this point to that point, and the distance from that point to that point is the one that we denote by b. So this b just helps us to sketch the curve. Alright, so we have been given that the center from the focus, or rather the distance from the focus, from the center to the focus there is 6 according to this coordinate, because we've been told the coordinate of the focus is 6, 0. So this tells us now that the orientation of this curve is in the x, because when you look at the focus is there. It's 6, 0. So 6, 0 is somewhere there, and I'll approximate my vertex to be there, and then the other vertex to be there. So I'll expect this point to be -6. Okay, and these are the asymptotes. Okay, so now we have to find the value of b. We have to find what b is and what c is. So c, according to this equation, according to the hyperbola, is the distance from the center to the vertex. So this distance is the one that we denote by c. So according to this forecast that we've been given, the value of c is simply just equal to what? 6. So we know the value of c to be 6. So now we know that the eccentricity has been given to be 3/2. So eccentricity is 3/2. So we say 3/2 is equal to, we have c over a here as as we have c over a here as the formula for the eccentricity. So we have c, and c here has been given, okay, let me say c over a, but we know that c, we found c to be 6, so we say 6 over what? Over a. So now the value of a, when you cross multiply there, is going to be, so we cross multiply 3 times a, we get 3a, 2 times 6, we get 12, meaning the value of a is simply just equal to what? When you divide 3 on both sides, you get the value of a to be 4, meaning our a squared is equal to what? 16. So we have found the value of a squared. We know the value of c is 6, and c squared can, when you calculate the value of c squared, this will give us what? 36. So c squared is simply just equal to 36. So c squared is simply just equal to 36, and a squared is 16. So we can use this formula to find the value of b. So c squared is equal to a squared plus b squared. So when you do the mathematics there, discover that the value of a squared is simply just 20, because when you replace c squared here with 36, so we know 36 there, and then a squared is 16, we say plus b squared. So the value of b squared is equal to, we have 36 minus, this will cross the equal sign, it will go this side, so it will be minus 16. So our b squared becomes 20. So let me now write the final equation, the final standard equation which I want us to find. So this is now going to be equal to, so since it's in the x, we expect x to be positive. So we say x squared over a squared. So our a squared is 16, and then we write a minus there, and then we have y squared over b squared. In this case is so b squared in this case is simply just 20, and this is equal to 1. So this is our equation. This is a standard equation for our equation, or rather for the question. Let's quickly move on to the other question on coordinate geometry. So these questions are part of the exercises that I gave you. So I believe they are not something new to you. Okay. So this is the other question that I gave you as the exercise. So the question says, find the eccentricity of the ellipse given by the equation 8x squared. So we've been given 8x squared, then plus 9y squared is equal to 18. So now we've been told to find what the eccentricity is of this equation. We know that the eccentricity of the ellipse is given by c over a. So now this is the formula. So to find the eccentricity, we need to know what c is, and we also need to know what a is. And to know that, we have to make sure that we reduce this equation to its standard form. So according to the ellipse and the hyperbola, this part should always be 1. So how do we make this part to be equal to 1? We divide the whole equation by 18. So when you divide the whole equation by 18, you discover that this part will become 4 over 9 x squared, and then plus this part will give you y squared over 2. Yeah, because 9 into 9 is 1, 9 into 18, that will give you 2, and then this side will have 1. So this is our equation. So to make sure that at least you don't get confused when dealing with this, always ensure that the coefficient of x on the numerator there is 1. So how do you do that? You take this part to become the denominator of x. But when doing that, you always have to be careful. So this will become 9 over 4. So the numbers will switch there. Then we say plus y squared over 2 is equal to 1. So according to this equation, you agree with me that our a squared is the biggest number between the two. That's according to the rules of the ellipse. So we know that the two numbers, this one we have, this is 2 point something. Yeah, because when you divide 9 by 4, you get something like 2.25, something like that, which is bigger than 2. So this tells us that our a squared is simply just equal to 9 over 4. And the remaining number there is the one that becomes our b squared. So b squared is equal to 2. Right. So since we have found a squared and b squared, we can now find what c is, because we need to find c for us to find the eccentricity. So to find c according to the ellipse, we know that c squared is given by a squared minus b squared. So c squared is equal to, our a squared is 9 over 4, and our b squared is simply just 2. So when you do the subtraction there, 9 over 4 minus 2, this is going to give us, so our c squared is simply just going to be, when you find 9 over 4 minus 2, or rather minus 2, this will give us 1 over 4. When you find the square root of both sides, you find the value of c as 1 over 2. Of course, it's supposed to be plus or minus. Yeah, but we deal with absolute values because these are simply distances. So we just get a positive part. Alright, so 1 over 2 is the value of c. So now to find the eccentricity we know that it's given by c over a. So the value of c has been given to be 1 over 2. And then when you divide this by a, the value of a was 9 over 4. So we divide this by 9 over 4. So eccentricity becomes 1 over 2 times 4 over 9. So eccentricity is simply just 4 over 18, which can be reduced to 2 over 9. Alright, so this is the procedure you're supposed to take to find the eccentricity when you've been given the equation. So this is how you're supposed to do it. Alright, so this was the last question for this tutorial. If you have not yet subscribed to the channel, make sure that you click on the subscription button, and also don't forget to click on the notification button so that you don't miss out the videos that I'm going to be posting. And if you have any questions or you want to join the online classes that I'm conducting in mathematics, physics and chemistry, feel free to contact me using these lines on the screen. My name is Harmtedy. Shalom, shalom.